Are all correct solutions truly correct solutions? Well, we have to remember a couple of things. First, we have to remember that when we're talking about a rational expression, remember we're talking about a fraction. In fractions and equations, we just got to make sure that we do not get 0 in the denominator because we get undefined terms. So yeah, it may become a solution to the problem, but when we truly go back and plug it into the original problem, it doesn't work for us because it's extraneous. We got to keep that in mind. Okay, so let's talk about our steps for solving a rational equation. We're going to get both sides of the equation to be a single fraction by finding the least common denominator and combining the terms to make it look like a proportion. From there, we can cross multiply and simplify. And when we're done, we're going to check our answers for extraneous solutions against the original equation. So let's take a look at this problem here. And when we do, we kind of say that what is the common denominator for the left side of the equation? We come to find out that it's 2x. So we need to multiply the second term by 2 over 2 so that we can combine like terms. Now, that will give us 5 divided by 2x plus 10 divided by 2x equals 1/3. Well, 5 plus 10 now can go together because we have the same denominator of 2x, leaving us 15 divided by 2x equals 1 over 3. We're going to cross multiply the 15 and the 3 with the 2x and the 1, and we get 2x equals 45. We then divide both sides by 2, and we get 45 divided by 2. Now we have to keep in mind how many answers we're going to get. Because this is x to the first power, we're going to get one answer, which we did. If we have x to the second power, we could get 2 possible answers, x to the third power, 3 possible answers. So we want to be keeping that in mind. Just because it's a possible answer doesn't mean it works. We have to go back and check for extraneous solutions. In this problem, x cannot equal 0 because 2 times 0 would be 0, and that would be 0. So we've got to keep on the lookout for extraneous solutions. So looking at this problem, how would we begin? Well, this is already set up as a proportion, so we could cross multiply. We get x times x plus 4 on one side equals 12. Once we distribute that x out to get x squared plus 4x, we have to decide what we want to do. We could complete the square to continue this, or do what most people would do because it's easier, is to get it all on one side so you can factor it. So we do that and we get x squared plus 4x minus 12 equals 0. We use the diamond method to factor out that trinomial, and we'll get x plus 6 and x minus 2, set them both equal to 0, and solve them to see what our possible answers are. We could get -6 and +2. Are any of these solutions extraneous? The answer is no. These are both good solutions. The reason is the only answer we could not get was -4, because -4 plus 4 would give us 0. All right, let's go ahead and start practicing a few of these. Here we have a proportion, x minus 3 divided by 4 equals x minus 4 divided by 3. We're going to start out by cross multiplying. 3 times x minus 3 equals 4 times x minus 4. We're going to distribute the 3 out, and we'll get 3x minus 9. And here distribute the 4x, and we'll get 4x minus 16. Now, it doesn't matter which side you put things on, as long as you put the things that go together on the same side. We're going to collect terms, so I'm going to go towards the more positive x's. So I end up with -9 equals x minus 16. I'm going to add 16 to both sides. And I get -9 plus 16, which is 7. And 7 works for us because we don't have anything that would be extraneous because we don't have any variables in the denominator. Let's take a look at another problem here. X divided by 4 equals 8 divided by 2x, already proportion. So we're going to multiply 2x times x equals 4 times 8. 2x times x is 2x squared. 4 times 8 is 32. We're going to divide both sides by 2. And find out that x squared equals 16. Now, because of the squared, we know we're going to get 2 possible answers, so we're going to take the square root of both sides to find out that x can equal plus or minus 4. Both of these are good answers because the only answer we could not get was 0 because 2 times 0 is 0. So we can keep both of those answers. Let's try it again with the binomial now in the denominator. When we cross multiply, on one side we'll get x times x plus 5. And on the other side, we'll get 18 times 2. We distribute the x out, we get x squared plus 5x. On the other side, 18 times 2, which is 36. We'll subtract 36 from both sides, and we collect all the terms on the left. X squared plus 5x minus 36, that's going to equal 0. We're going to use the diamond method and figure out what this is as a trinomial, what will be as two binomials factored. Once you do that, you will get x plus 9 times x minus 4 equals 0. You're going to take each of these binomials, x plus 9 equals 0, and x minus 4 equals 0, and you're going to solve for them. So in this first case, we'll subtract 9, find out that x equals negative 9. In the second case, we're going to add 4 and find out that x equals 4. So these two solutions will both work for us because the only thing that x could not be is negative 5. And because of that, these will work. Now, you can solve problems one of two ways. Just go ahead and solve and worry about the extraneous at the end, or decide what the extraneous is at the beginning, then solve, and then cross it out once you get it. Let's try that this way with this problem. Here, we want to make sure that we do not get 0, because 4 times 0 is 0, or putting a 0 there. So that's the only number we don't want to get. So we have two terms on the left-hand side, so we need to find the least common denominator. We're going to use 4x. That means we need to multiply the second fraction times 4. Our common denominator of 4x, here we have 3 plus 5 times 4, which is 20, will give us 1. 3 plus 20 is 23. And every number is put over 1 to make as a fraction. And we will cross multiply. 4x times 1 is 4x. 23 times 1 is 23. We'll divide both sides by 4. And we find out that x equals 23 fourths. I know that sometimes we get an improper fraction or a fraction in general and we think it's not going to work. I'm going to show you in a check of this problem that it does work, and not to be afraid of getting something like this. See, well, here the 4's will cancel and this will just reduce down to 3 over 23. Here we have 5 divided by 23 fourths, which we would multiply by the reciprocal. Once we do that, we would get 20 23rds. Well, 3 plus 20 is 23, and since this is supposed to equal 1, which it does, this indeed is a good answer, and we didn't get 0. So that would tend to let us believe that we're doing and we're on the right track. Here, we're not going to have any extraneous solutions because the denominator is 6, 10, and 5. So we can just proceed in finding a least common denominator of 30. Means we're going to multiply top and bottom here by 5, this one by 3. That way we'll have a common denominator of 30. 5x minus 3x is going to equal 1/5. 5x minus 3x is 2x. And we're at the point where we're going to cross multiply. 2x times 5 is 10x. 30 times 1 is 30. We're then going to divide both sides by 10. And we find out that x equals 3. And again, we said no extraneous solutions, so we're good to go. Let's take a look here at this problem. And hopefully I'll be able to show you something very interesting. Least common denominator is going to be x plus 3 times x minus 3. So we notice that this one's going to need an x minus 3. And this one's going to need an x plus 3. So x plus 3 times x minus 3 is x squared minus 9. So here we're going to have 1 times x minus 3, which is x minus 3, plus 1 times x plus 3, which is x plus 3, divided by, or equal to, 1 over x squared minus 9. Let's combine terms. X times x plus x is 2x. Negative 3 plus 3 is 0. All over x squared minus 9, 1 over x squared minus 9. We're going to cross multiply, and when we do that, we get 2x times x squared minus 9 equals x squared minus 9. We're going to distribute out that 2x squared, 2x to the x squared, we get 2x to the third. 2x times 9 is negative 18x, and on this side we have x squared minus 9. We're going to try and put everything together on one side, so I'm going to subtract an 8x squared and add 9 to both sides. When I do that, I'm going to get a very long 4-term polynomial. And we have to remember how to factor those. We're just going to start out by cutting it in half and pulling out the common term, which in this case would be x squared, leaving behind 2x minus 1, writing that binomial to the other side. And this one times negative 9. So our two binomials are 2x minus 1 and x squared minus 9. If we factor x squared minus 9, we get 2x minus 1, x minus 3, and x plus 3 equals 0. I'm going to continue, and I know it's getting smaller, but stay with me on this because I'm going to show you a shortcut in a moment. We're going to take each of these and set them equal to 0. So 2x minus 1 equals 0. Add 1. 2x equals 1, divide by 2. So far we know x can equal 1/2. Here, x minus 3 equals 0. If I add 3 to both sides, x can equal 3. Here, x plus 3 equals 0. If I subtract 3 from both sides, x can equal negative 3. Now I got 3 solutions because I had x cubed, so I'm going to get 3 solutions. So let's go back and take a look. What can x not equal? Well, it cannot equal 3 because 3 minus 3 will be 0. Cannot equal negative 3 because negative 3 plus 3 equals 0. And look, I got 2 of those answers. So I'm going to throw them out and they're extraneous. So the only answer that will work for me is x equals 1/2. Well, is there a way to get rid of the extraneous solutions before I go through all of this? And the answer is yes, there is. It's right here. And I'm going to kind of zoom back in so that you see where we went. Okay, if we're back here at this point, where the denominators are exactly the same, we could have just crossed them out and gone to this point here, 2x equals 1, and solved from there by dividing by 2, and we find out x equals 1/2. What that does earlier, and that's what we found out way down here, what that does is by canceling out the denominators early, if they do cancel, we will get rid of the extraneous solutions and we never have to really think about them. So now why is this allowed? Why am I allowed to do that? Let's think about this. 2/5 equals x divided by 5. Intuitively, you should be able to look at this and say, yeah, 2 equals x because 2/5 equals 2/5. Well, couldn't I just take out the denominators to find out x equals 2? So it's the same idea. Okay, so let's see if we can try and practice that on this last problem. So here I have 5 divided by y minus 3 minus 30 divided by y squared minus 9. I know the least common denominator is y minus 3 and y plus 3 because y squared minus 9 factors into that. If I multiply top and bottom by y plus 3, that will give me 5y plus 15 minus 30 all divided by y minus 3 and y plus 3. And another way is keep things factored until the last minute. Because if you can cancel early, we can work some things out. Here I'm going to get 5y minus 15 divided by y minus 3 times y plus 3. I can factor out that 5y minus 15. I can pull a 5 out of that, y minus 3. Y minus 3, y plus 3. And I can cancel those y minus 3's. So if I didn't cancel early, one of the solutions I would have gotten would have been 3. And if we think about it, let's go back up here. 3 minus 3 is 0. I did not want to get 3. So by taking this out early, I could get rid of one of those solutions. Okay, let's see what else we're going to come up with here as we continue on. So we're going to, let me go to a full view for you. So it'll be easier instead of scrolling up and down. Okay, let's continue and we'll get 5 divided by y plus 3 equals 1. We're going to put 1 over 1 and cross multiply. So we get 5 equals y plus 3. Finish the problem off. We're going to subtract 3 from both sides. And we get 2 equals y. So that is our solution because the only thing that wasn't going to work for us was 3 and negative 3. Those were not going to work for us. And by taking one out earlier, we got rid of that. Now, had we left that y squared in there, it may have popped up maybe 2 or 3 solutions, but we know we got rid of 1. So by going earlier and trying to cancel earlier, you should be able to get rid of your extraneous solution. So hopefully this will help you in solving rational equations.